Hello, Tutor Polly here, back with another question. And today I'm going to focus solely on C because I think there was enough here to talk about C. Limits are weird, and it's one of the first things that we learn about in calculus. This is a one-sided limit because it's asking the limit as x approaches 1 from the right side. Okay, so that means you're from the right going left. Okay, whatever the function looks like. Now we're going to do this algebraically. I think it should be very clear that you have to factor this. You have to resolve this. Now one of the first things with any limit is that you would plug in the actual value. Well, if you plugged in the value here, what's going to happen? The value is 1. If you were to plug in 1, you're going to get 1 minus 1 on top and 1 minus 1 on bottom, and you're going to get 0 over 0, and that's a problem. Okay, but you should check because sometimes a teacher might put that on a homework or a test, and you'll plug in the value and it'll be a number, and that's a valid number. Okay, what we're trying to solve is the dividing by zero error. Okay, so you really need to be able to recognize how to factor these things, ignoring the square roots for the time being. This is a difference of squares. So if I have a squared minus b squared, that is the same thing as a minus b times a plus b. Okay, that's a difference of squares. So this is, on the bottom, x squared minus 1 squared, okay? And so I can factor the denominator to be x minus 1, x plus 1. Now, you didn't absolutely have to do this, but I think it's worth doing. I think it's worth noting. So we did. Now, we should also factor the top, but this might be a little bit more challenging. What is common to both terms? The first term has an x to the fourth. The second term has an x to the second, so they both have at least x to the second, x times x. They're both there. The first one's x times x times x times x. The second one's x times x, so they both have x squared. Okay, so we're going to pull the x squared out. Okay, so if I factor out an x squared, that's x squared minus 1. Now this is what I was saying. You didn't absolutely have to factor the denominator, but I think it's you should know how to do it for sure. So now we're just going to factor the numerator the same way. So now we have x squared, x minus 1, x plus 1, okay, all over the square root of x minus 1, x plus 1. It should be fairly obvious that these are identical. Well, we just need to know one more algebra rule, and that is being able to separate things that are roots if they are multiplied or divided. So for example, if I have the square root of a times b, that's the same thing as the square root of a times the square root of b. Maybe a different example. If I had the square root of 9 times x, that's the same thing as the square root of 9 times the square root of x. The 9 escapes the root, and the square root of 9 is 3. Plus or minus, but in this case we'll just say plus. So that's an example there. Now, why do I mention that? Because we need to separate the things here, so we're going to do that. So now we're going to have, we're going to separate out the things that are the same so that we can now cancel them. All right. So now we have the square root of x squared times the square root of x minus 1, x plus 1, all over itself. The square root of x minus 1 times x plus 1. Those two things are the same, so they cancel, and we're happy about that. Yay. Okay, now we're just left with the square root of x squared. Well, the square root of x squared, that's just the square root of x. We've now simplified it, and we now no longer have any fraction. So there's no dividing by zero thing that could possibly happen. Okay, so now we have the limit as x approaches 1 from the right of, oh, I'm sorry, not the square root of x. It's going to just be, they cancel out. So we just have x, right? Sorry about that. So we just have the limit as x approaches 1 from the right of x. Okay, and that's great. So if we were to plug in 1 at this point, you would just get 1. And essentially you're saying x is approaching 1, y should be approaching 1. But they did say from the right, so if you weren't absolutely sure, you could plug in 1.0 0, 1, okay? And you would get out 1.001, okay? So I believe the answer is 1. Now, why did they give us a one-sided limit, right? They didn't say as x approaches 1. They said 1 from the right. Well, you can't really do this unless you're wanting to check. You can't really do this on a quiz or an assessment. But if we were to graph the original function, okay, and I have here, here it is, okay, and we're saying as x approaches 1 from the right. Well, here is 1, interesting looking function, by the way. And if you were a little bug on this thing and on this graph, you cannot deviate from our plot here, the red line, the red curve. And you would approach x equals 1 from the right. You're approaching y equals 1. Okay, that's you're going towards that location. Okay, you can't actually go there because that would be a divide by 0 error, but you are approaching it. Okay, so the answer is 1. But I guess another question for you: what would the limit as x approaches 1 be if the function is not defined there? If you can't really approach it from the left because there's nothing, there's no plot on the left. Okay, so I love this chart here. This is a great chart. I'll leave this in the comments. Help you understand how to do limits. The left side must equal the right side in order for the limit to exist. But this was only a one-sided limit. Okay, so the answer will be 1. I hope this helps. Thanks.